Hi all, I am Vivek, postgraduate student, Department of Information Technology, Kannur University. Let's see what is today's topic. Automata is an abstract model of digital computer. Every automaton has some essential features. It has mechanism for reading input. It's assumed that input is a string over a given alphabet which automaton can read but not change. Transition of an automata from one configuration to the next is called a move. We have two types of automata: DFA, that is deterministic automata, and NFA, that is non-deterministic automata. In DFA, each move is uniquely determined by current configuration. That is, we know all the internal or the initial states, inputs, and we can predict future behavior exactly. In NFA, we have several possible moves, so we can predict a set of possible actions. So the definition is given by M equal to Q, sigma, delta, Q0 and F, where Q is the finite set of states, sigma is the finite set of input symbols, Q0 is the initial state, F is the final state or the accepted states, delta is the transition function given by Q cross sigma. In NFA, the range of delta is power set of 2Q, that is, its value is not a single element of Q but a subset of it. The subset defines all set of possible states that can be reached by transition. This includes a transition without consuming an input, that is our lambda transition. Now arises the question, why non-deterministic? Non-deterministic is a difficult concept. Digital computers are completely deterministic and the state at any time is uniquely predictable from input and initial state. So the question arises, why study them? For example, a game playing program. We need to progress and not aware of the best move when we have several alternatives. So we choose one and follow until it becomes clear that if that was the best or not. If it was not the best choice, we come back to the last point and explore another choice. A non-deterministic algorithm that can make best choice would be able to solve problem without backtracking. Now let us see examples. Construct an NFA that accepts all strings with 0 and 1. So the solution contains three states, starting from the initial state Q0, then Q1 and our final state Q2. Note that we have just mentioned the best solution among all the possible values here. Another question, construct an NFA that accepts all strings of length at least 2. So the solution contains three states Q0, Q1 and Q2. The next question is to design an NFA in which double 1 is followed by double 0. Total of 5 states Q0, Q1, Q2, Q3 and Q4. The next question is to design an NFA based on the transition table. The table is given below. We have Q0, Q1, Q2 and Q3. Here we have constructed the NFA based on the data from the table. Q0's 0 transition loops to Q0 and Q1. Q0 1 transition goes to Q0 and Q2. Q1 0 transition moves to Q3 and Q1 1 transition is epsilon, that is it's not present. In Q2 0 transition goes to Q2 itself and Q3, and in Q2 1 transition goes to Q3. And for Q3, 0 transition loops itself to Q3 and 1 transition also loop itself to Q3. We have seen some examples to construct NFA. So here it is given some workout problems for you to solve and understand NFA better. The question is to construct an NFA that accepts all strings that begin with 1 and end with 0. From the question, we write down the general language to be the finite set collections of 10, 110, 100, 1100 and so on. So based on this language, we will construct the NFA. And for the next problem, we have to construct an NFA where strings contain some A's followed by some B's followed by some C's. Here the sigma is given as collection of A, B, C and an epsilon. So it is now possible to transition through epsilon as it is given. Thank you all. Hope this is useful.